Welcome back to our next lecture on a new set of data types, integers and floats. An integer is a whole number that's not a fraction. So for example, numbers like 5, 19, and -22 are all integers, while a number such as 2.23 would not represent an integer because it's not a whole number. We can perform all of our basic mathematical operations on integers in Python. So we can use the addition operator, a plus sign. We can perform subtraction, multiplication, or division using the following operators here. We can also use two multiplication signs to represent exponentiation. Recall that anything inside quotes represents a string. So if I call the print function and print 5 inside of quotes, my argument is not the number 5, but is instead the character 5. So what we're actually printing here is a string. However, if I print the number 5, the integer 5 without quotes, what we're printing on line 4 is an integer. When I run this, they sure look like the same output here, and we're going to learn later on how we might be able to distinguish those two outputs. We can perform all of our basic mathematical operations with integers. So for instance, I can do addition, so 4 plus 2. I could do subtraction, 4 minus 2. I could do multiplication, 4 times 2. I could do division. We'll do 4 divided by 2. And lastly, I could do exponentiation. So I could do 4 raised to the second power. And let's run this and see what we get. So not that much of a surprise here. It looks like we're printing our 5s, and then we have the result of all of our mathematical operations. So 4 plus 2 is 6. 4 minus 2 is 2. 4 times 2 is 8. 4 divided by 2, if you notice here, and this is interesting, we get 2.0. So what is returned here is not an integer, but instead it's a decimal value. These decimal values are known as floats. And a float, so therefore a float is any number that is a decimal value. For instance, I could say that 2.2 is a float, or 4.10 is a float. All of our mathematical operations work with floats as well. So for instance, if I have a float, and let's store this float in a variable, because we can actually store integers and floats and variables just like we could with strings. So I'm going to say y is equal to 4.15, and we'll say print y. If we run this, we print our float 4.15. Right? It's what's the value of the variable y. I can update the value though. I can say, hey, let's say y is equal to the current value of y plus 2. So we'll take whatever is currently stored in the variable y and add 2 to it. So if I print y now, instead of reading 4.15, it should read 6.15. And it does just that. This is a common way to notate changing or updating a variable's value, but we can also do this using the following notation. I can say y plus equals 2, and this says take the current value of y, add 2 to it, and update the value of y, make that the new value. So now if I print y, it should print, for the last time, 8.15, and it does just that. We have a similar idea if we want to decrease the value. So I could say y is equal to y minus, we'll say 1. And if I print y here, I could also say y is minus equal 1. And so that will decrease the current value of y by 1. So if we run this, we see 8.15, we decreased it by a value of 1, 7.15, and then we decreased it again to 6.15. So there's some of our basic mathematical operations with integers and floats. We're going to look at these a little bit more in depth as we move forward. Wonderful.